Okay, so now we know the event of the coordinates of Luke's arrival at Alderaan. Now let's consider what happens with the light signal that Luke also sends out when he leaves Dagobah. Um, the light signal has obviously a speed that's equal to c, so beta equals 1. It travels a distance l, and so the vertical coordinate in for the light signal's arrival at Tatooine, where Han is equal to L. Sorry about that. So let's call that event B. Okay. So now we have that we know that this is L. Okay. And this distance is 5L over 2. And so what we know is that this basically time coordinate here is equal to 5L over 2 minus L, which is equal to 3L over 2. So this is essentially the amount of time that Han has to be able to get from Tatooine to Alderaan. And so now all we have to do is calculate his speed. We know the distance he has to go. We know the time that he has to do it, and so it's easy to calculate this. Okay, so remember that the slope of a world line is equal to the change in time divided by the change in the position, which is 1 over beta. So beta is equal to inverse of that. So beta is equal to basically the change in position for Han, L over 2, divided by the change in time coordinate, 3L over 2. And so we see immediately that Han's speed must be equal to 1/3. Well, beta, his speed relative to light, must be equal to 1/3 in order for him to get to Alderaan at precisely the same time that Luke does. Now let's draw the world lines of all of them. Just basically connect the dots. Okay, so here we go. The line that connects A and B is just the light line. Okay, that's the world line of a beam of light or a signal. The line that connects B and C is Han's world line. Okay, and the line that connects A and C is Luke's world line. Now, keep in mind that in this particular example, we're assuming that Luke and Han accelerate from rest instantaneously. That's obviously not realistic, but if the amount of time that they spend traveling at constant velocity is large compared to the time that they spend accelerating, this is a reasonable approximation. And in any case, we're just sort of trying to learn how to, this is sort of a qualitative exercise at this point. Okay, now let's figure out what happens when how do you change between reference frames? How do you go from one reference frame? How does the space-time diagram change when you go from one reference frame to another that's moving with respect to the first? Okay, and this is called boosting. So to think about this, let's imagine that Luke sends 2 messages to Han with a time interval tau. So the time between the 2 signals that he sends we'll designate as tau, and the Greek letter tau. And so in this situation, there are 4 events in the reference frame of Luke and Han. The first thing that happens is that Luke sends his first signal, and the next thing that happens is that Han receives the first signal. The third event is that Luke sends the second signal, and then Han receives the second signal.